So after learning about partial fraction, we are all ready to do some inverse Laplace transformation. Basically, I will cover 5 examples, and all the rest complex examples you see ultimately will turn out in this 5. Ultimately the problem will turn out about these 5 problems. Alright, so firstly, we want to inverse Laplace transform this function 1 by s plus 1 square. So whenever you see something that a first order factor square, you should think of this as the derivative of a first order factor. This 1 by s plus 1 square is the derivative of 1 over s minus 1 with a minus sign, because the derivative of 1 by s plus 1 is equals to minus 1 by s plus 1 square, so minus minus gets cancelled out. So if you have a higher power in the denominator, you should express it in the form of derivative. If it was 3, it should be second derivative. Alright, now the inverse Laplace transform of this is simply e to the power minus t u of t, and as it is derivative, there should be a t here, we know from property, with a minus sign, as it is first derivative, and there is a minus sign from earlier. This minus and this minus gets cancelled out, so ultimately inverse Laplace transformation is this. Alright, so now we want to move on to our second problem. So the second problem is that we cannot factorize it, but we can take it somehow into a cosine form. In the numerator, you can take it into something s square, s plus something square, plus some other thing square, right? S square minus twice s plus 1 plus 2 s plus 3. Alright, this is simply s plus 1 square plus root 2 square plus s plus 3. Alright, this looks like a cosine or sine form very well, right? So as s plus 1 here, we are going to take s plus 1 in the numerator, in the numerator also, and rest 2 is going to come on over here. Now this looks a lot like cosine form, except instead of s there is s plus 1, so it's going to be cosine of root 2 t a to the power minus t, as there is a shift in s domain and u of t. And this looks like sine form, except if it would have been sine, then there should have been root 2 here, there should have been root 2 here, so we are going to take root 2 here and root 2 out of our fraction. So there is root 2, and the Laplace transformation, inverse Laplace transformation of whole this thing is going to be sine of root 2t e to the power minus t u of t, right? E to the power minus t, because there is a shift of plus 1, and in the time domain there will be shift in exponential with a negative factor. So that's how you can solve for things which in the denominator you can make out this sort of form, that something s plus something square plus some other thing square. But here you cannot make such form, because if you try to make in this way, x square minus 2s plus 1, then there will be minus 4, so you can never make something square plus something square. It will be a minus, and there is no formula, inverse Laplace transformation formula for that. So here your only way to solve is to probably factorize it, either by your middle term or either by your minus b plus minus root over b square minus 4ac divided by twice a formula. Here you can solve it easily by middle term. It's going to be s minus 3 s plus 1. Alright, and we know how to partial fraction it. S plus 3 s plus 1, the root is s minus 3, so root is simply 3, so 3 plus 1 is 4, 3. And here the root is simply minus 1, so minus 1 minus 3 is minus 4, and minus 1, so minus minus gets cancelled out, so 3 by 4, 1 by s minus 3 plus 1 by 4, 1 by s plus 1. And the inverse Laplace transform of this is simply e to the power minus 3t u of t, and the inverse Laplace transform of this is simply e to the power t u of t, 1 by 4. Alright, so that's how you can do it. You can see if you can make something square plus some other thing square, some function of s square plus some constant square, then it's better to, you have to take it in the cosine and sine term. And if you can factorize it, then you can do it in a very simple and straightforward way. Now the fourth problem. Okay, so fourth problem is simply our third problem with an e to the power minus s added, right? Now we know when we get an x e to the power minus s in Laplace domain, when you shift in time domain, right? When you shift in time domain, there is e to the power minus s in the Laplace domain. The inverse Laplace transform of this function, we found out it right now, is going to be 3 by 4 e to the power minus 3t u of t plus 1 by 4 e to the power t u of t. Now as there is a shift in the s domain by minus 1, so there will be a shift in time domain by minus 1, so that means you have to replace t as t minus 1 to find out the Laplace transform of whole of this function. So you just replace t by t minus 1 everywhere and you have come up with your answer. You got it right, because when you change t as t minus 1, there will be an extra negative factor of e to the power minus s here. Okay, so that solves our fourth problem, and now we have come out to our fifth problem. All right, in the fifth problem, firstly what many people would have do is try to do partial fraction or other things, but they don't notice that this is an improper fraction. So try to use long division and make it proper. So how can I use long division? We should try to make the term on the denominator in the numerator, and the term is already present, so it will be very much straightforwardly easy. So it's going to be 2 1 plus 2 s by s plus 2s square. So this is simply the pattern of cosine, and this is simply delta of t. Inverse Laplace transformation of 1 is delta of t. So if we do inverse Laplace transformation, our result is going to be 2 delta of t plus 2. This is simply result of cosine of 2t u of t, and that's how we have found out our inverse Laplace transformation of our this function. So 5 tricks. I have tried to make sure there can be complex problem in which you might need to do a lot of partial fractions, but after you do partial fractions you will come back in these 5 qualitative problems only. So firstly, you can have denominator power extended very much, where you should try to relate it with derivatives, right? Secondly, you can have two sort of form, one where the denominator can be expressed as some function of s square plus some constant square. Another time it cannot be expressed in this form because there will be a minus. You cannot express it some function of s square plus some constant square. Then you need to factorize it. You must factorize it, and then the exponential factor, if there is an exponential of minus s factor, then you shouldn't worry about it. First find out the in Laplace transformation without the exponential factor, and then replace t by the exponential shift t minus t naught. All right, and then fifth crucial rule is that never do partial fractions or other sort of works without, if it is not a proper integral. If it is an improper integral, first make it a proper integral by long division. All right, so these are the 5 tricks of Laplace transformation. In the next stage we are going to go to the application of Laplace.